Okay, class, this is the last video for lesson 4.3, solving linear systems using substitution. Here's the quick notes, which I failed to show you last video, and I wasn't going to go through that again. So I'll just include it here. The quick notes. Substitution is used. Okay. This method is used when one variable is already written or can easily be written in terms of another. That's when you use it. A lot of times it will be y equals some expression in x, and then we could take that expression and substitute it into the other equation, because you have to have two, to reduce the number of variables from 2, y, x, and y, to 1, x, or y, or s and b, or whatever we have, okay? Use the relationship between two variables to write one variable in terms of another. Okay, we're solving for one of the variables. Then substitute the equivalent expression into the other equation so only one variable remains. Now it's a simple, well, relatively simple, one equation, one unknown. So we solve for the variable. And then we substitute the variable in for the other variable in the other equation. Like I said, the steps are a little bit crazy. All right, so luckily this is already put into yours, because I decided that having you write it takes too much time, and as long as you understand what the learning targets and the quick notes are, you're fine. So let's do this last one. There was a total of 34 people at the family reunion to feed the crowd. 140 ounces of pulled pork were prepared. 5 ounces of pulled pork is portioned for each adult, and 3 ounces of pulled pork is portioned for each child. Let A be the number of adults and C be the number of children. All right. So can we write an equation describing the relationship between A and C? Okay. Well, we know since there is a total of 34 people, okay, since we know this, that means A, the number of adults, plus C, the number of children, must be equal to 34. That's an equation. Okay, that is an equation. All right. And from this, we can get either, by subtracting C from both sides, we can get A equals 34 minus C, or we could subtract A from both sides and get C equals 34 minus A. Either one, doesn't matter which one it is, all right? Then write an equation for the total amount of pulled pork needed in terms of A and C. Well, the total amount is 140 ounces of pulled pork, as portioned out, let's see, 5 ounces of pulled pork is for each adult, so each adult is 5 ounces. So that would be 5 times A, that's the total amount of pulled pork for adults, plus 3 times C, that's got to equal the total amount of pulled pork you have, which is 140. This is an amount for adults, total, and the 3C is children's total. Add them together, and that's got to equal the 140 ounces of pulled pork you used. All right, so now we have a second equation with two unknowns. All right, so the question is, determine the number of adults and the number of children at the reunion. Clearly show your reasoning. Well, we have two equations and two unknowns. We can use the top white equation, this one, right up here, to replace one of the variables in the bottom equation. All right, and for lack of anything better, I'm going to use the fact that C equals 34 minus A. So this bottom equation becomes 5A plus 3C, but remember, C is 34 minus A. And that's got to equal 140. Okay? So we get 5A plus 3 times 34. Let's see. I'm distributing, right? Boom, boom. So 3 times 30 is 90. 3 times 4 is 12. It's 102 plus 102 minus 3A equals 140. 5A minus 3A is 2A plus 102. And that equals 140. Subtracting 102 from both sides, isolating the variable, gives us 2A equals 38 and A equals 19. So there were 19 adults. Okay, 19 adults. So since we know A plus C equals 34, or the fact that C equals 34 minus A is 34 minus 19, we get C equal to 15. So there were 19 adults and 15 children at the reunion. Okay. So what strategies did we use? Well, we started with 2 equations each time. Or every time. Okay. Sometimes the equations had 2 variables. But in question 1, there was only 1 variable. Question 1, there was only 1 variable in one of the equations. Which made it easy to solve. This made it easy to solve. Okay? We saw how the 2 variables were connected and used it, were connected and used that connection, that to rewrite one of the equations in only 1 variable. Okay. And there you go. All right. Pretty long and pretty tough. So anyway, that's it, and good luck.